Welcome back to Impact Quantum, the podcast for the quantum curious where the bits are entangled, the hosts are excitable, and the science is anything but classical. I'm your host, Frank Larvine, joined by Candice Gilhooly, the most quantum curious human in the known multiverse. Today, we've got a real treat for you. Joining us is Harshitta Gandhi, quantum machine learning engineer, graduate of Northeastern University, and someone who, when faced with a quantum supremacy paper that made no sense, thought, right, time to make this my entire life. We'll dig into her journey from confused comp SCI undergrad to quantum startup maven, touching on machine learning, security in quantum circuits, and why truly random numbers are more than just something you use in a Vegas slot machine. Oh, and she's worked on both superconducting and photonic quantum systems because apparently, one flavor of quantum just wasn't enough. If you're wondering what the future of computing might look like, or just want to hear Frank wax poetic about Q hash and GPU hoarding, then settle in, grab a Schrodinger's snack that may or may not be cheese, and enjoy the episode.
Hello and welcome back to the Impact. I almost said the data-driven one. Sorry about that. Let me edit that out. Hello and welcome back to Impact Quantum, the podcast for the quantum curious. And with me today, I have Candice Gilhooly, who is probably the most quantum curious person I know. And as you can tell, Candice, I got that right. I nailed that intro. Like, I'm not one to toot my own horn, but it took us a number of episodes to come up with that. So how you doing, Candice?
I'm doing great. Thank you so much, Frank. I'm really excited today. We have a fantastic guest with us,
Yes.
Harshitta Gandhi. I'm very excited to speak with her today. I'm always a fan of when we have a woman that we're speaking with. It's just nice also to get the female perspective. And she's generous enough to give us some time today. So thank you so much.
Yeah.
No, it's my pleasure. Thank you. Thank you for having me. And I'm very happy to be here today. And I'm with you. I'm on with you on the page that we need more people to talk about quantum computing and quantum machine learning in general. So I am quantum curious too. So thanks for having me. Yeah.
So you were research assistant. You were a grad student. You have your advanced degree from Northeastern. You're in Boston, and so tell me about. Because I'm looking at your resume here, and it's awesome. So if you're looking, I don't know if you're looking for a job or not, but I would totally hire you if I were in the quantum space. Just saying, if I had a company.
Thank you. Yeah, that's the kind of person I need.
Yeah, exactly. So there's a lot to unpack here, but just seeing your title right under professional experience, quantum machine learning engineer. Tell me a little bit about that, because I think that is going to be a growth industry. Based on the guest we had on a previous show, who was also a woman, actually, she was talking about how much impact quantum computing can have on machine learning. So tell me a little bit about what you do and what your research is.
Sure. Thank you for that question, actually. So I did my undergrad from India, from New Delhi. And during my undergrad, in my junior year, Google actually released the quantum supremacy paper in October 2019. And that was the first time I got introduced to quantum computing as a field. Before that, I knew what quantum mechanics was, but never grappled with that idea in a very, very affirmative sense. I'm not a physics major. I did not do my undergrad in physics or any of those pure sciences, if you call them. My undergrad was in computer science, and when this paper came out, I tried to read that, and I did not understand a word of it. Not one word of it. So that's when my journey into quantum computing began. I started reading more about it, I started, doing math, which was important for quantum computing and quantum mechanics as a whole. And as soon as Google, like this paper came out, and I started doing all this, COVID hit. So I was at home for the next 2 years. That is like quantum computing is all I did. So um, if you ask me, not going to college was like the best thing ever for me. So
Okay.
so yeah, so that's where I started studying my quantum mechanics, my mathematics, my physics, my computer science, and everything. Um, and one of the best resources that I used was Umesh Vazirani's lecture series on YouTube. It's amazing. It takes you through quantum computing step by step. So yeah, during my undergrad, I started doing quantum computing, but most of my focus was on theoretical quantum computer science, right? And when I did my internship at TU Delft in the Netherlands, that was also the time where I was introduced to a lot more concepts in quantum information and quantum, just theoretical computer science. Um, but recently, my focus during my master's shifted on quantum machine learning. So it has been a trajectory, and I am actually really glad that I took this trajectory to quantum machine learning, because quantum machine learning is something very right now I would say in its infancy, it's in its nascent stages. So there's a lot to go, but what exactly it pertains is that in classical machine learning algorithms, take make the machine learn each instance at a time, right? Each path is observed one at a time. But what theoretically is happening in quantum machine learning, that all the possible paths, or all the possible computations necessary for a program to learn, are happening simultaneously. So that's where quantum computing benefits machine learning, like lesser training times, lesser memory, lesser data required. And so that's where quantum machine learning comes in, and that's where it's actually helpful.
So it's not just about so one, it warms my heart because I have my undergrad's in comp sci.
Okay,
It warms my heart that when you first looked at quantum computing, you were also very confused because
definitely.
I don't feel like the dumbest guy in the room, which is nice.
Okay.
Because I had a very similar experience. Obviously, I'm quite a bit older. But when I heard of quantum computing, like it was like, yeah. But when it first really dawned on me, like this was a thing and it was going to be a thing, was also in 2019. And I
Hmm.
was at I snuck into, well, I had legitimate tickets, so I didn't really sneak in. I was in a Microsoft research conference,
Hmm.
and the keynote was all about hardware. And at the time I was, so what? I just need more GPUs, right? And when that's not enough, just get more GPUs. And then we were talking about how GPUs are not enough for the future, and basically introduced me to the idea of quantum computing in the context of machine learning and optimization, route optimization, that sort of thing. And I was blown away. So much so, like later that night, I went installed, Q Sharp development kit, on my laptop. And then I was like, okay, now what? Right? Because I was just like, I felt like I hit a wall, like a cognitive wall of like, wait a minute, this is not what I'm used to. It's not traditional computer science. So I was
Yeah.
very glad to hear that I was not the only one confused. And anyone with the sound of our voices, if you're confused, there's a quote, and I think it's Richard Feynman, if you think you understand quantum mechanics, you don't understand quantum mechanics.
Yeah.
Um, and the other thing is too, like when in the context of quantum machine learning, and this could be my misunderstanding, you said that it's learning all different things at the same time. I was always under the impression, could be wrong, that it was really more about somehow the quantum algorithms were able to work out the global minimum much faster than finding it kind of hit and miss with traditional methods. So it seems like it's more than just that.
So, if you see a black box, that's what you see. So you
Right.
actually see that the quantum algorithms have found the global minima very quickly, right? Faster than the classical algorithms. But then how did they do that?
Right.
So how did they do that? So it's basically, I mean, you have to traverse the field, right? You have to go through every path to figure out what the optimum path is. So if you are taking one path at a time, you're gonna take a longer time. But if
I
you're traversing
see.
all four paths simultaneously, you're gonna find a global minima or the optimal path faster.
Okay, that makes sense. That kind of
Okay,
bridges those two concepts. And for my networking geeks, because this popped in my head too, it's kind of like the difference between packet switching and circuit connections, right?
that yeah,
It's not
sure.
exactly the same. I know, and
Yeah.
I know I'm gonna get a
But
lot of
if
hate
you
mail
want
on
to
that.
draw like
Right.
a
An
similarity, that's a good thing. Yeah. Yeah.
analogies always break down, but like if you're
Hmm.
just if you're already struggling to get your mind over this wall, that's a good little rope to cling to.
Right.
Um, so that's cool. So what are you doing now? Because you mean you are doing quantum machine learning now. Like what are the sorts of problems you're working on? Are they just typical machine learning problems? Are they specific to say NLP or something like that?
So, during my graduate school, I was working on mostly computer vision problems,
Okay.
working with MNIST, fashion MNIST data sets. I worked on similarity of images. I worked on generating images, and then I worked on classification of images. Um, but recently, and then I also worked a little bit on security in quantum computing. So I think this is something we should talk about because most of the quantum computers these days are available through the cloud. So and as quantum computing progresses, the business needs of quantum computing also progress, right? So if you're sending our code into the cloud, and so our code is very visible to the service providers. So to obfuscate that code, we devised like my lab at Northeastern, they devised an algorithm which would just insert X and RX gates in the circuit, like randomly insert X and RX gates, um, and that's how the service providers would not get to know what the circuit is actually doing, but we as writers of the circuit could always reverse the circuit and get the output. So I think that is something that was very interesting. And so most of my work has been on superconducting qubits. But again, as the quantum landscape expands, I also worked a little bit on photonic quantum computers, which was again a very interesting area to go into because the math is actually different for superconducting and photonic quantum computers.
Yeah, talk
Um,
to me about that because like
Yeah.
it's hard to find an expert in one,
no,
But
I
you
and
dealt with
wouldn't.
two.
in
So,
two, that's even more of a rare
right.
gem in gem in the mountain. I don't know, like you know where I was going with that. So
Yeah, explain that. That's really interesting,
what
especially
I
for
mean, like,
science.
is the code because like we spoke to someone recently and said like by and large, if you're at like the software writing level, it's
Mhm.
largely abstracted away.
Yeah.
But that sounds too good to be true to me.
No, it is actually
Okay.
by and large on the software level, it's very similar. It's just that you need to understand. So to write algorithms or to come up with new solutions to problems, you do need to understand the underlying quantum qualities of a particular modality. Right. For example, if you're working with superconducting qubits, you're limited to the topology of the circuit, right? Of what is it called? Yeah, the topology of the circuit, right? Of how the qubits are connected. But if you look at something like ion trapped or neutral atom quantum computers, you can actually make the connections yourself. You can actually form lattices to and see how the qubits are connected to each other. So even though the software level is mostly the same and the programming languages and um, yeah, just how you compute the things that you want to compute are very similar to each other, but then you do need to understand the underlying quantum qualities of that particular modality. So, yeah,
Interesting.
yeah,
Interesting. So I guess that affects how you design the software, even if it's abstracted.
yeah,
This you're a comp sci person, so I can say like the design pattern is going to be different or
y-
maybe better suited based on
yeah,
the underlying hardware. Okay.
yeah, definitely, definitely. And this also leads me to my next point that certain modalities, just because of the underlying quantum qualities of a particular modality, some applications are more suited to certain modalities. I have not tested this, but I have a strong intuition that certain applications, for example, if you like off the top of my head, if you just take genome sequencing or protein building. So I feel like I don't know which modality, but I feel like certain modalities, like for example, let's say neutral atom quantum computing would be more suited to genomics applications rather than superconducting qubits. So, but that's just my intuition. I have not tested this yet. Um, but right, currently I'm working with a startup called Qubit Solutions Research,
Hmm.
and they had a financial quantum algorithm. So,
Interesting.
yeah, yeah, it is very interesting. Let me give you a little bit of overview about that. So the founder of the company has actually a business accounting background. So, and he also somehow got very interested in quantum computing. And what he did very sophisticatedly was coalesce the two concepts, coalesce the concepts of a quantum world, I would say, with the financial transactions, with the business financial world, right? And he actually intertwined. He actually created an analogy out of both around both of these concepts, and it comes together beautifully. Um, so he has that algorithm, and he wanted someone to implement that into on like real machines, so that we can run on real machines and see where that leads to. So that's what I've been doing recently.
Very cool. So see, Candace, the quantum curious are
Yeah.
awesome because
Oh,
this
yeah.
guy was an accountant and he probably could have been perfectly happy doing accounting finance things for his, but like he's doing something transformative just by being curious. So it proves your hypothesis, Candace.
No, that's fantastic. And that could lead us actually to our next conversation, which would be about, all the news that's coming out every day. You have Microsoft, you have Google, you have JP Morgan. It just, there's so much news to listen to, so much is being developed every day. Is there a particular announcement that who's more academic minded, I would say, um, a particular announcement that you're excited about?
Oh, me. Um, Honestly, I it's a lot. It's a lot of, there's also a lot of hype that's been created around quantum, and I feel we should cut through that. And I feel that's very important because I know that quantum computing, promises a lot of things, and a lot of benefits, but then I think we have to stay grounded in the reality of what is happening these days. And honestly, I came to that realization a long time after I should have. But yeah, that's okay. But I think now I'm grounded in the reality of quantum computing. But I really like I'm actually interested to see what AWS does next. They introduced a chip called Ocelot and on Amazon, and that I'm actually interested in looking at. And I'm also interested in looking at Microsoft's cat qubits. Was it Microsoft? Yeah,
Yeah.
yeah.
Majorana.
Majorana, yeah, exactly. So cat qubits is another like a very interesting development, I would say, because that actually reduces the error rates in the hardware itself.
Right.
Yeah, it seems like
So,
And
the
that's
error
very
correction
big
is a
concern.
big engineering blocker right now.
Yes.
yeah, I think so too. So, yeah, but I actually don't know what you're talking about, JP Morgan. Would you want to
Yeah,
like
so
bring me up to date with that?
they made an
Yeah.
announcement that they can create and I know this is the dollar store version of the announcement. Um if anyone's involved in that project wants to tell me how wrong I am, hey, come on the show. Um they created a quantum computer that can create truly random numbers, right? So
Oh,
not no more of the pseudo random number generators, and even if you stack pseudo random numbers generators together, it's still not really random. So that's the big breakthrough, and it really puts them, at least in mind share, at the
mhm.
top of the field of financial institutions that are embracing quantum.
Yeah.
um, Whether or not how that will result in practical performance, I think is too soon to say. But true randomness is one of those things that will come in handy in a lot of different ways, and probably a lot of different ways we can't imagine yet.
Right.
So that's basically kind of
Mm-hmm.
the dollar store explanation of it.
Mm-hmm.
Um, but
But it seemed like out of very left field, right? Like
right.
it seemed out of left field to me. Not that they don't have any right to do it. Of course they do. I just felt like it. I wasn't expecting that, and then it kind of seemed that it made a lot of sense.
Most
Yeah.
people, when they hear about quantum research, you think
Mm-hmm.
Microsoft, you think D-Wave, you think Amazon, Google, like all the
Mm-hmm.
usual suspects. You don't think about a bank, right?
Yeah. Mm-hmm.
And I think that's what caught people like, wait a minute, you're playing with this? Like, what's going on? Like,
Mm-hmm.
but to your point, like 2025, I think has been a good microcosm of the quantum industry for like at least since 2019, right? A lot of hype, a lot of anti-hype,
Mm-hmm.
right? And we kind of overhype, and then there's too much anti-hype, right? So Willow came about in December, right?
Mm-hmm.
And
Mm-hmm.
then Jensen Huang at CES is like, this is decades
Yeah.
away. And then all the stocks tanked, and then
Yeah.
like a week or two later, Bill Gates is like, "Hey, I think you might be wrong on this." And then a week and a half, 2 weeks ago, Jensen's back on stage saying, "Hey, sorry about that, folks. I tanked your stock portfolios." Um, but it's been an interesting year, and I'm starting to see it really heat up
I know.
to the point where that's what, besides Candace's perseverance and persistence and marketing prowess on selling me the idea of restarting it, how we got restarted, because it really is. I'm just finally starting to see it catch on. I think a lot of people, I think it was overpromised in 2019, and then the pandemic, and kind of like it's never really materialized the way we were promised. And even
Yeah.
internally, when I was at Microsoft, there were a lot of field people who were also at that same. I was a field sales rep at the time, who were also in that same room with me, and we started talking about quantum to our customers,
Hmm.
wording it like, "Hey, this is just about to come out," because that's kind of what we're used to. You go to these events, and they're basically showcasing what's coming out in the next 18 to 24 months. And so much so that somebody from the Azure Quantum team had to like invite us to a talking to, like, hey, look, it is cool, it is very real, but it's not going to be customer ready for quite some time, right?
Yeah. Mm-hmm.
And I think that you're right. Like, you do have to field between the hype, because it's certainly I oscillate between this too, right? Like, I think like any day now there's going to be that breakthrough.
Any day, yeah.
But it's not. Like I also know it's not. I also know it's not going to be 10 years. It's probably in the 3 to 5 year horizon. And also too, like one of the previous guests we have kind of said, well, a lot of this depends on what you mean by practical quantum computer, right? Do you mean a quantum computer you connect to in the cloud and it's just a regular service that, the hyperscalers provide, right? Or, do you mean like you go to the store and you buy a QPU, like it's like you would do a GPU, right? And you plug it into your conventional, right? Are you going to have a Q phone, right? Is Apple going to announce the Q phone? Like so practical. I think we are decades away from the Q phone, but in terms of being able to put one in your massive data center, if you're a major corporation like JP Morgan, probably not that far away. I mean, theoretically, you could do it now. You can probably buy a D-Wave. I mean, I don't have the budget for it. Like, if I balk at buying a $2,000 GPU, I'm definitely going to balk at buying a quantum computer. But but I think it's very real. But I think it's very real in pockets.
Yeah.
So I think that. But you're right. Like, it's a lot of hype, a lot of anti-hype, and the truth is somewhere in the middle.
Yeah.
And I'm optimistic, but I'm also realistic, right? Like, my day job, I work with AI because that's what people want now, right? And it's fun too. But I think I'm also hedging my bets that, because not too many years we're going to have kids in college, and I also need to have a viable economic future. And, it really comes down to, this is an industry that even if you're just taking big tech, right? Like the only course I took in college that as a comp sci major that is really stuck and hasn't really altered much and or whatever that technology stack is the SQL Server or the relational database design course that I took. Like the fundamentals of that have not really changed much. But everything else in technology is not a thing. Like, Pascal is not a language that anyone cares about anymore. COBOL, I took a COBOL course actually just for fun. People only care about that because they have to, but it's not a growth market, right? Like, so like C#.net didn't exist. All these things didn't exist when I was at college. And it's one of those things where if you're in this field, you have to love constant learning.
Right.
Yes.
And I ranted a lot. So sorry, Candace, you can ask her some questions.
No, I'm agreeing with everything. And it's also interesting, right? She explained that she didn't go, she went an alternate route to get to her education.
Right.
And I find that also to be incredibly fascinating, especially with being a parent and raising, Generation Z and Alpha children to, show them that there are alternative ways to get to your end goal. I always say it's not where you start, it's where you end up.
Right. And it's not like the olden days, like our parents' generation, where like, it was pretty prescribed, college, college, then job, then, corner office, and then retirement. And then it's not that way. Like, I mean, I've changed jobs. I'd have to look at LinkedIn to be sure, but at least a dozen times. Right. And that horrified some members of my family because I'd be at one place for a couple of years, then I'd go and like, they were that generation. You stayed somewhere for 20 years. Horrified them, but and like I kind of wonder, like, what's the job market of the future going to look like? Is it going to be mostly a freelance world? Is it going to be? I don't know. Like, but I have kids, and like you get to the point where you're like, I have to prepare them for not the world I grew up in, but the world that they're going to live in. And those are very different worlds. And I'm not that old,
but I also,
right?
But I also think that the fact that you're combining quantum and machine learning is incredibly captivating.
Absolutely.
It's a step deeper than other people are at currently. And I like to consider myself to be fairly technically literate, but I think that is a good position to be in, especially in this burgeoning quantum world where the people who are involved, they want other people like you who are able to communicate what's going on, why it's practically necessary, et cetera, et cetera. And so, even though you were explaining some very high end things before, like it made sense even to me as the curious, um, to where you were going. Oh, yes, that's all I wanted to mention.
And
Yeah,
it's just a field that's ripe for the curious. We were talking about this, how this is a field it's kind of, it's not really, it's out of the lab now, right?
it
It's clearly
is.
out of the lab, but it's
Yeah,
also not like in mass production either.
yeah.
So it's in this weird, awkward adolescent phase of it's not quite like we use the automotive industry as an example, right? How, you know, uh, right now the automotive industry is the automotive industry, right? You don't even have to qualify it, right?
Hmm.
But at some point, it went from a bunch of dudes playing around with little internal combustion engines or whatever with wrenches and stuff and
Hmm.
grease all over them to massive multinational corporations. Same thing with technology, right? It went from,
Yeah,
if you look at the picture of the founders of Microsoft, like where there was like just 12 people, and
yeah.
like they went from that to what it is today in the whole industry. There is a very weird adolescent phase, and I don't think any of us in this call are old enough to remember what that was like in technology, right?
No.
So we're kind of seeing it. And it's probably the first time in a while.
Hmm. Um,
Um, yeah,
Apart
sorry.
from, I just want to quip in a little bit.
Yeah.
Apart from just academia and then going on to the industry, like to multinational organizations or technological giants, I feel like there's a lot of startups in quantum computing. There's a lot of people trying to tackle very, very minute, very minuscule problems in quantum computing, and I feel like somewhere in the near future, if we could coalesce all this together to actually implement and actually just take the research that the even the startups have done and implement them to at a larger scale. I think that would be very helpful as well. Like I want to, yeah, so like the quantum computing startups are also like very rigorous and very interesting, and not just the technological giants that we talk about or see the news about actually.
Yeah. No,
No,
I
I
think it's a
So
good
agree.
way to
and
look at
and
it.
and we've spoken to a couple startups, and
mhm,
like we said, it's a really vibrant ecosystem,
yeah.
that is, there could be a lot of collaboration that goes on that could
Hmm.
really, extend where they go in the next 2 to 5 years.
Exactly. Yeah.
Absolutely.
Yeah. And I think in a field like quantum computing, collaboration is the key. Collaboration is the key because there's so many different aspects to this one concept. There's so many different aspects. There's computer science, there's physics, there's electrical engineering, there's like so many different aspects about quantum computing that not one person in the world knows all of them. So I think that's where collaboration comes in, and I think that is the key to making quantum computing successful.
No, absolutely. I think, and like, so what do you think, what's next for you? Like you're early in your career, you're relatively fresh out of school, and you've already, looks like you've already, landed a speaking gig in Dubai, which is really cool.
Thank you.
Um, I saw that one sheet about that you had presented that, and so like where do you think it's going to go in the near future, and when do you think, like, not when, but like what do you think the world's going to look like once it really becomes, the hype becomes more real than not real?
That is actually a very good question, and I think that involves a lot of hypotheses.
Right.
So I
Predicting the
wouldn't say
future is hard, right? That's why
yes.
Vegas makes so much money, because it's
Yeah,
impossible, just about impossible to predict the
it's
future.
impossible. But what I would say that Yeah, I absolutely agree that quantum computing is somewhat out of academia and is going into the industry, but then there's also a lot of kinks that we need to iron, and there's a lot of, minute details that we need to iron out. Um, so for me particularly, I actually like to work on I'd like to actually work in a smaller scale startup rather than just go into a bigger organization. It's just because that I like that kind of creativity and I like that kind of freedom um, of thought and of implementation also. I do recognize that the end goal is something that we should have in mind and we should look at the bigger picture um, from time to time because I was not looking at the bigger picture during my graduate years, right? I was very focused on the details. I was very focused on, oh, how this one line of code, changes the program. I was very interested in, oh, what kind of optimizer to use. But then
Right.
through that, I like after a lot of, not after a lot of, conscious effort, I have tried to look at the bigger picture. So I think that, and that has actually helped me a lot. That has actually helped me move forward. Because again, there's a lot of nuances to quantum computing that we need to iron out, but then I don't think that we should get stuck to those nuances, right? I think we should take them in stride and,
Right.
look at the bigger picture. I think that's very important for the near future. For long term, for like 10 years down the line, I think once we have somewhat standardized version of quantum computing, be it any modality, um, I think we can start to look at more applications, look at more things that could help um, that would help the society and also the environment.
Right.
So I do understand that quantum computing itself takes a lot of energy, but then at the same time, I think that would reduce the amount of burden that is on super computers right now. Um, so scaling down from supercomputers and moving on to quantum computers also feels like a good idea for the environment. But I could be wrong here. Maybe quantum
I
computers
think you're
use more
right on that.
energy.
I think you're
Yeah.
right on that. I think that
Okay.
one of the big controversies where I live is they want to build a new high power line between 3 Mile Island and basically Dulles Airport, where all
Okay.
the lot of the Microsoft data centers are,
Uh-huh.
AWS too. But there's a lot of power goes into compute, like, and you hear people talk about like the amount of energy that's needed to do a regular Google search result versus, the Gemini search result. Like it's not trivial.
It's
Now, I
not.
think the jury is out on is how much more power efficient quantum computers will be, right?
Yeah. Yeah.
And also too, like you can also kind of nitpick at it, right? Like, well, the computer's more efficient, but I also have to cool it at like near
Yeah.
absolute zero, so I kind of lose some efficiency there. But no, I mean, you're right. I think it's hard to imagine it being more power intensive than what we have
Yeah.
today,
Exactly.
right?
Because supercomputers will use like a lot of energy to compute.
Right,
And we're going to need more space, more data centers, but then if once quantum computers are, you know, built and established, we don't need that much power to just compute more things, right? Because
right.
there's like exponential increase in the computational power. So I think they'll be a little more beneficial for the environment as well.
No, I think you're right. Because even like to your point, like if it draws the same amount of current, the amount of output you get for that current is going to be better. So that's like the
Exactly.
worst case scenario. So the
Yeah.
worst case scenario is still better. But no, it's a good angle. I hadn't really thought about that yet because it's like
Mhm.
it's still too new to think about what the TCO of a quantum computer would be, right? Like, it's not like, if I rack and stack a Xeon chip and whatever, and like a couple of GPUs on it, like I kind of know what that'll cost. I kind of know what the depreciation of that is and all that accounting nonsense. Like, that's already been figured out. The quantum computer, it's not,
Mm-hmm.
nah, you don't have like 20 years of like, what's its lifespan going to be?
Yep.
You just don't have that, right?
Mm-hmm.
I think it just shows you, like, to your point, like it's not a science project anymore. This is very real.
Yes.
It's just there's not a lot of people with experience making it real yet.
Yeah.
And that'll come in time. But people like you, I mean, you're probably going to be the CTO of, some of these, big quantum companies and stuff. I mean, they're not big now, right? But you look, I mean, the best way to predict the future is kind of look at the past. And I look at like early founders, like, Candace and I were talking about this today, there was a time and place when you could go to a computer users group in Berkeley, California, and it
Mm-hmm.
would have Steve Jobs smoking a cigarette, talking to Steve Wozniak, and Bill Gates would have been there too, right?
Right.
Well, I think we're kind of in that phase now where like
Right.
the people that we meet today at these little like quantum events, they're going to be the Jeff Bezoses, the Bill Gates, the Steve Jobs of the future. Not everybody wins the lottery, but a lot of people will, be influential in the space today and in the future. So we've been
I'm
honored to
sure.
speak with you. We've been honored to speak with
I
you. Um, you know, um, uh, any parting thoughts, Candace?
No, honestly, I was thrilled to listen. It again gives me much more perspective, substance behind everything that I'm learning, and to see where the future is going. And yeah, she's brilliant.
She is
And
brilliant. One day we'll be on
and
her yacht or whatever, and she'll be like, we'll interview her.
well, definitely.
There you go. But
Yes.
well, I mean, like it's just, I think it's just such a raw opportunity field, and there's
Yeah.
obviously very real engineering blockers. The first to come to mind is error correction. But I
Mhm.
think that once the walls start coming down in terms of like the technological barriers, the conceptual barriers of people at large are going to be the next thing to work on. And then
Yeah.
people like you, people, I dare say, like Candace and I, who are kind of getting our feet in this water, in this space, getting our head around some of these non-traditional concepts, we're going to be at a better advantage when that wall does come down.
I
Might come down
agree.
next year, might come
Mhm.
down in 5 years, but it's coming down,
It
right?
is coming
I don't,
down.
I don't think it's going to be 20 years, but
No.
um, but it will come down within my lifetime, within my career working lifetime. Like, it's coming down. And I think the best time to be ready for that is get ready
Right
today. So
now. Right
right
now. The
now,
best
right.
time. Right now. Yes.
Absolutely. And I
Absolutely.
know, I just think that people who are positioning themselves now just by being curious, like Canada, right, are going to open up a lot more opportunities. Like the accountant that you worked with, right? Like,
Mhm.
he was curious, so he wanted to know
Yeah.
more about it, and like he is in a different place. And the fact that you also have a comp sci background, which a lot of the people in quantum computers tend to be quantum physicists, tended to be,
Yes.
right?
Yeah.
So just having kind of like, you and I both know how comp sci people think and what we kind of learn generally, right? So just
Mhm.
having someone with that kind of software understanding of like how to build and ship software and algorithms, as opposed to focusing on just the physics of it, which is also important.
Mhm.
It's kind of like, well, back in my day, like the difference between electrical engineering majors and comp sci people, right?
Mhm.
There was a
Yeah.
lot of overlap, but it's different disciplines and different mindsets.
I actually I understand that. It's
Yeah,
again, it's very it's a lot of overlap between quantum mechanics and quantum computing, but
yep,
then the way we look at problems or the way we tackle challenges is like absolutely two different mindsets.
absolutely. Any
Yeah.
parting thoughts, Candace? I know I asked you that already.
uh yeah, so I gave my parting thoughts before. So I'm just really happy that we had you on
Awesome.
today, and we look forward to speaking with you again.
And Harshita, where can
As
people find out more about what you're up to?
Uh, I'm I'm only on LinkedIn, so I
Okay,
know it's yeah, I'm very active on LinkedIn.
cool.
Feel free to look out for look up Qubit Solutions Research on LinkedIn. It's an
Okay.
amazing company, and we also put out a paper on ResearchGate, So, and we're gonna soon put out a paper on archive as well.
Oh,
So,
very
yeah,
cool.
maybe, yeah.
I will be on
So,
the
just,
lookout
yeah,
for that. And we'd love to
yeah,
have you on the show again when you have new research to publish and we can talk about that.
definitely. Yeah, yeah,
Awesome.
I will definitely be in touch with you. Yes.
Awesome. And we'll let our
So
AI
excellent.
finish the show. That was
Okay.
great.
And that's a wrap on this episode of Impact Quantum, where we boldly go where few algorithms have gone before. A huge thank you to Harshita Gandhi for quantum leaping onto the show today. From fashion mnist to photonic qubits. From security in the cloud to deciphering the hype cycles, Harshita reminded us that the future is not only coming, it's probably already been parallel processed. As always, if your brain feels slightly entangled after today's conversation, that's perfectly normal. Just apply a Hadamard gate and get some rest. You can find Harshita on LinkedIn. And her work with Qubit Solutions Research on ResearchGate and soon, R14. We'll be watching and occasionally decohering with excitement. Until next time, stay curious, stay coherent. And remember, in the quantum realm, even your podcast player is probably in superposition. Goodbye from all of us in the quantum cloud.